Hi everyone. So before we get started, I just have a little announcement. So we are currently a bit ahead of schedule with the semester's work. So we won't be having a lecture on Friday, tomorrow, and we won't be having a lecture on Monday either. Okay, so we'll start off again on Tuesday with the tutorial. Okay, so no lecture tomorrow, no lecture Monday. Okay, so let's get started with today's work. So we're going to go through the solutions for the formative tutorial quiz. Okay, so formative tutorial quiz 3. Okay, so question 1 was asking to construct a unit vector that is orthogonal to both the vector A, and that was given by 1, -1, and 2, and vector B, that's given by 1, 2, 3. Okay, so if we're given two vectors, A and B, and we want to find something orthogonal, we need to use the cross product. Because remember how the cross product is defined? If you have vector A going this way and vector B going in some other direction, it doesn't matter where, then if we do A cross B, it will give us a third vector that is guaranteed to be perpendicular to both of them. Okay, so if A and B lie in some plane, then the cross product A cross B is guaranteed to be normal to the plane. In other words, orthogonal to both. So A cross B is normal to the plane containing A and B. Okay, if you want to imagine A and B in a plane, then A cross B is normal. And so A cross B is orthogonal to both A and B. Okay, so that's the geometric picture that you should keep in mind. If you have A and B, you take the cross product. The cross product is always perpendicular or orthogonal to those two vectors. Okay, so we should all know how to take the cross product now. So that is the determinant, where the first row is the I, J, and K unit vectors. So A cross B. First row is the I, J, K unit vectors. The second row we put down A, so that's 1, -1, 2. And the third row we put down B, that's 1, 2, 3. Okay, then we take the cross product, so we put down R first. And then we're going to have -3, -4 as the first component. Then we have -j, don't forget the minus here. Okay, you have to put -j. Then that's going to give us 3 - 2. And plus k, and that's going to be 2 + 1. Okay, so these are going to be the components of our new vector. So you can either simplify and leave it as a sum. So we can write this as -7r -j plus 3k. You can leave it as the sum like that, or you can write it as a single vector as -7 -1 3. Okay, either way, that's fine. Okay, so this is going to be a vector perpendicular to A and B. However, the question asked for a unit vector. So we need to take this vector, A cross B, and divide it by the length of the vector. That will make it a unit vector. So make this a unit vector. Okay, so we do that by taking A cross B divided by the length of A cross B. And that will be a unit vector. Let's call it n hat. Okay, n for normal. So remember the hat, that means it's a unit vector. Okay, so let's find the length of this vector. So A cross B, magnitude or length or norm, however you want to say it, is going to be the square root of the first component squared plus the second component squared plus the third component squared. So that's going to be 49 plus 1, that's 50, plus 9, so that's 59, root 59. Okay, so we've got the length of the vector. If we take the vector and divide each component by the length of the vector, then the new length will then be 1. So we have n hat is going to be 1 over root 59. We divide by the length, minus 7, minus 1, and 3. Okay, and in the tutorial session, I said there were 2 possible answers. That's because if we look at this perpendicular vector, it can either go up or it can go down. Right? So we can also have a vector going this other way, and it's still orthogonal. Okay, because remember, like I said with the normals, the normal can go up or the normal can go down. Both are orthogonal, so both are normals. And remember, that's just a minus sign difference. So this is minus A cross B. So minus A cross B, or you could say B cross A. Okay, remember the minus sign flips the order of the operation. Okay, so we can just put a minus sign and then that will give us the other normal. Or we can have, so we can call that n1, n2. That will be minus 1 over root 59, minus 7, minus 1, and 3. Okay, so either are accepted as being orthogonal to those 2 vectors. Okay, any questions on this first one? Okay, let's have a look at the next one. Okay, so the next one was find the area of the triangle with vertices, and then they were P 001, Q 121, and R 110. Okay, so the first thing that you should do is just draw a rough picture of what's going on so that we can then construct the sides of this triangle. So rough triangle, just like that. And you can put down the vertices anywhere, it doesn't matter because this is just a rough diagram. So let's say this is P, let's say that's Q and that's R. You can put it anywhere you like. So now that we've got our triangle, we need to pick 2 of the sides. Let's take this side, PQ, and let's take this other side, PR. Of course, you can choose any sides, it doesn't matter. Okay, so PQ, let's call that side A vector going from P to Q. Okay, so this vector going along there is going to be the vector going to Q minus the vector going to P, and that will give us the vector going in between the 2. So let's call that A. That's going to be the vector going to Q minus the vector going to P, and that will give us our A vector. And for the other side, it's going to be something like that. Let's call that B. That's going to be the vector going to R minus the vector going to P. That gives us the vector going in between the 2 points. Okay, so we've got 2 of the sides. That's all we need. Next, we need to take the cross product between the 2. Okay, so let's find out what A is. So A is Q minus P. So Q is given by 121. P was given by 0, 0, 1. That's going to be 1, 2, and then the 1 minus 1, that makes a 0. And then B, that was R minus P. So R was given by 1, 1, 0. P was given by 0, 0, 1. So that's going to be 1, 1, and then 0 minus 1 will be minus 1. So 1, 1, minus 1. Okay, so these are the two sides of the triangle. Okay, so remember how we find the area. We take the cross product. That gives us the area of the full parallelogram produced by the sides. But we don't want the full parallelogram. We want half of it to make the triangle. So the area is going to be 1/2, because we're only interested in the triangle portion of A cross B. Okay, so let's find the cross product. So A cross B, that's going to be determinant R, J, K. Let's put down A first, so that's 1, 2, 0. Then we put down B, that's 1, 1, minus 1. And we expand this out as the determinant. So we start off with the R, and we left with minus 2 minus 0, so that's just minus 2. Minus J, again, remember it is minus J. And then that's going to be minus 1 minus 0, so just minus 1. And plus K, it's going to be 1 minus 2, so that's just minus 1. Okay, so you can either leave it as the sum, so you can write minus 2R plus J minus K, or you can write it using the tuple form. Both are accepted. So you can do minus 2, 1, minus 1. Okay, so both ways I'm happy with. Okay, so we've got the cross product. Now we need to take the magnitude of the cross product and then halve it. Okay, so magnitude of the cross product. That's going to be square root, each component squared. So minus 2 squared plus 1 squared plus minus 1 squared. That's going to be root 4 plus 1, so root 6. Okay, so that would be the area of the parallelogram, but we're interested in the triangle, so we need to halve it. So area of the triangle is going to be root 6 over 2. And if you want, you can write unit squared, but I'm not too worried about that. Okay, any questions on this one? Okay, let's have a look at the last one here. So number 3. Okay, so 3, we were given the following question. Simplify, and then we had A cross B plus C dot product with A plus B. Okay, so we know that the first thing we need to do is distribute over the cross product. So if we have A cross B plus C, we know that this can be distributed over the plus. So this is equal to A cross B plus A cross C dot product with A plus B. Okay, so we've distributed over the plus there. Next, we've got another product, the dot product. We can also distribute over that. So we're going to have that dot product with this. Same thing with the next term. And same with the other term. Okay, it's your usual multiplication distribution. So the first one is we're going to get A cross B dot A plus A cross B dot B plus A cross C dot A plus A cross C dot B. Now, A cross B, that is a vector perpendicular to A and B. Okay, so I'm just going to do this for the first one here. If I've got A and I've got B, then A cross B is perpendicular. So if I take the dot product between this perpendicular vector and A, I'm going to get 0 because they are perpendicular to each other. So A cross B is perpendicular to A, which implies the dot product is 0. Okay, so that means this term goes to 0, this term goes to 0, and this term goes to 0. Okay, they all go to 0, and we're left with A cross C dot B. Okay, you can see that all of these vectors are different, so the dot product won't give us 0. Okay, so that's our final answer. Okay, any questions on this? Okay, cool. So like I said at the beginning, we're not going to be having a lecture on Friday, and we're not going to be having a lecture on Monday. Okay, so we'll carry on Tuesday with the Zoom tutorial in the morning, and then the in-person tutorial in the afternoon, where we will do the next summative quiz. Okay, and before we do the summative quiz next Tuesday, we're going to have a small revision session on vectors. Okay, so we're going to do a revision on vectors, do the summative quiz, and then the next lectures, we're going to be going through the new work on polar coordinates. Okay, so that's the new section to go through. Okay, if you have any questions, please ask on the WhatsApp group, or you can send me an email. I've got a question here. Why does cross product B dot C turn to 0? Because they're different vectors. So if I have A cross C, so let's imagine here I've got A, and here I've got C. If I take the cross product, it's going to be perpendicular to both of them. So that's A cross C. The vector B could be anywhere. Maybe it's something like this. Okay, with some angle between them. They don't have to be perpendicular to each other. So A cross C dot B is just going to be some number. Okay, not necessarily 0. So A cross C dot B is some real number depending on what this angle is. Okay. So if the angle is 90, then it's going to be 0, but there's nothing that says it should be 90. Okay, so this is non-zero in general. Okay, does that answer your question? Okay, cool. So I'll see all of you on Tuesday. Okay, bye, everyone.